Welcome to the Daily Space Weather, folks. We're looking at the sun, 193 angstroms here. Coronal hole system here, stretching all the way from above the equator down to the North Pole. Large zigzag-shaped coronal hole system. And a couple active regions there, 0 sunspots. 10.7 centimeter radial flux back down to 70. So solar minimum conditions persist. There's a smaller active region rising here, something to keep an eye on. And when I say ion, the pun's intentional. Here's the colorized magnetogram. And you can see this plage here, which never formed into a sunspot. Over here we have a degrading sunspot 2751. And down here we have a degrading sunspot 2750. Now they're not sunspots. They have since degraded into plages. Let's look over here on the east. Yeah, this area here on the east is the latest thing to look at, although it doesn't look like it's particularly organized as far as magnetic fields go. Here's the GOES X-ray imager. We did catch a small B-class X-ray flare yesterday. You can see that right there. Since then, no significant X-ray flares. And besides that's one small flare, the X-ray flux has remained basically flatlined. And there you can see that graph. Let's take a quick moment to look at the view from Stereo A. And there is a link to this site below the video if you'd like to look at this view yourself. Stereo A is out in space. And this is what we use to look at Earth-facing coronal mass ejections. We do see a large plasma plume there at the end. So there is a bit of plasma, and there could be a coronal mass ejection happening right as we're making the video, oddly. And let's move on to some more data, as there's a lot of stuff to cover. And we are going to be going back to a live format pretty soon, folks. It's just that we want to get the videos out in time. We're also going to be having shorter clips for people that only want to watch one section of the video. We're going to splice all those. Or I should say slice all those. Anyway. Well, the phi angle has just recently changed right there. You can see this shift. It looks like it's around a magnetic connection to the coronal holes again, especially if it stays around 180 degrees. It did that shift right as we started doing show prep. Is it a coincidence? Yeah, probably. Or perhaps it's divine providence. What say you? Leave a comment. Solar wind density, 3.69 protons per cubic centimeter. And solar wind speed has ramped down slightly from yesterday to 395 kilometers a second as forecasted. Here's the data from ACE. Looking pretty corroborative there. Here's the geospace magnetosphere movie. We're just showing you 4 hours of data here, folks, because reasons. Actually, it's because the data is not accessible unless you are running a constant screen rip of this. And here's our second track. This is called Stacker Do. If you want to hear the original music in full glory, head over to soundclick.com/smAsho. Not slash smAsho. Soundclick.com/goldencatproductions. It's linked below the video, so you don't have to type all that in anyway. So just click on the description box and check out all of our links. You may find some interesting stuff. And also please support the channel via Patreon, patreon.com/smAsho. Anyway, here's 4 hours of data, geospace delta B. We're talking about changes in the Earth's B field. And for you new viewers, the B field is the one that goes through the magnet. And there's a 10.7 centimeter radial flux. We've drawn on this orange line here to show you where 70 is. And that's where we currently are. 10.7 centimeter radial flux, by the way, is a measure of the outer corona of the sun as it emits radio frequency very regularly and very positively correlated with sunspot number. Here's a GOES magnetometer. More of a normal range for this. Nothing to write home about. But if you are writing home, we recommend you send a postcard about that because it's not really a big deal. Next, we see the Gong 2 data. We're looking at the top view ecliptic plane field plot. And this data is 1 hour and 38 minutes old, by the way. Now keep in mind the magnetic environment can change with 0 warning. And we still see this tug of war between the north and south going on in between stereo A and Earth. So you can see the field is changing in this area between red and green. Red associated with the south pole charge of the current sheet. Green associated with the north pole charge of the current sheet, as the Earth is constantly swinging between the two sides, or rather, the current sheet is constantly wobbling as the sun sends out a constant spiral of plasma. KP index back down to 1 after seeing it up to 2 for, 12 hours there. And let's look at cosmic rays. First, apatity. And there's the apatity neutron monitor. Here's Barentsburg. And here, headed out to Greece, the Athens monitor. And looks like they've got some missing data there, as cosmic ray monitors don't do that. And here's Mexico City. Part of the reason that I monitor these folks is because there seems to be some sort of inverse correlation between cosmic ray flux and solar activity. And so it's kind of important for this channel to check it out. Again, Mexico City here, 30 days worth. And we have linked to the page prior to this, so you can click all these links yourself if you want to monitor cosmic rays. Some of these are in faster updates than others. Some of them are 5-minute averages, 1-minute averages, and a lot of them have accessible data where you can look at the last cosmic ray maximum, or the actual cosmic ray maximum, which occurred around 2010. Anyway, there's Moscow's neutron monitor, 30 days worth. And it looks like they're missing some data also. And last but not least, Oulu, Finland. And by the way, thanks Ola Udrup for teaching me how to pronounce the word Oulu. I appreciate that. And you can see down here you've got the since 1965 chart, you've got the 30-day chart, and you've got the 5-minute average last 24-hour chart for Oulu. Here's the same system for Antarctica, although Antarctica does not send back the data the same way as Oulu does. And there's the DOMB Antarctica. And again, links to this network of cosmic ray stations site are below the video. Here's the GOES electron flux. We're looking at the GOES 15 and 14. Looking at pretty normal ranges there. And the relativistic electrons are looking a little on the high side, but not particularly intense. Next, we'll check out the ionosphere. And please leave a comment if you're a YouTube channel that uses our videos to view all this data in an easy fashion instead of having to go through all these websites yourself. Anyway, there's 6 hours of data from Government of Australia, Bureau of Meteorology. And let's bring up the latest image. Ionosphere looking pretty normal to me. Earthquake rundown. Largest quake of the past 24 was a 6.3 at the South Sandwich Islands. Let's do the rundown of everything over a 4 magnitude. 4.7 at Japan, 5.1 at Guam. Second quake there. Again, please leave a comment if you are viewing the videos from Guam or any place else for that matter. 4.3 at Colombia, and that one is at depth, heads up northern South America. South America is my favorite place for the magnitude 7 earthquake drought to end, folks, and it's been going on for a long time. 4.8 at Kamchatka. Is it associated with magmatic activity? I don't know. We're going to leave you in suspense and not look at it. 4.0 at Indonesia there. That one's at 74 kilometers. And there's that South Sandwich Islands quake right underneath my face there, close to the Antarctican plate. Next, we see a 5.1 in Afghanistan, as we've been seeing 1 or 2 Middle Eastern quakes every week. That one is at depth, so heads up Afghans for a larger quake at the surface. Next, we see a 4.3 at Chile, and that area right there is my favorite spot for a 7+ magnitude quake to kick off. We'll be watching that phi angle on the solar wind data to see if the phi angle ends up around 180 degrees and stays there, as we would not be surprised at all to see that coronal hole remagnetically connect, or I should say reconnect magnetically. Second largest quake of the past 24, I think, is this 5.9 at Vanuatu, as they also had a 5.1 and a 5.8 in that same location, so a little earthquake swarm there at Vanuatu. The area we call Oceania, where I would like to go for New Year's one year to be some of the last people to celebrate the new year. Just east of the international date line. The location? It's a secret for now. 4.5 at Mexico. That one at 28.2 kilometers depth. Next, a 4.2 at Japan. That one's at depth also. Coming in at 5:59 this morning UT. A 5.0 at Mexico. We see a 4.9 at Vostok. That's Vostok, Russia. Not to be confused with Lake Vostok in Antarctica. That one is also at depth. And lastly, just coming in, as we did show prep, a 5.3 at Iran, another Middle Eastern quake. Next, we'll take a look at pressure maps on windy.com. Windy.com also offering a great mobile app, so thanks for that. We're going to just let this advance 24 hours. If you see some anomalous low pressure system behavior, folks, and you're in an earthquake-prone area, hey, have an earthquake plan. Be prepared in the event of a disaster. Be an asset, not a liability. If you're wondering who the cavalry is, it's probably because it's you. Next, we'll look at volcano discovery for today's volcano rundown. Regular viewers are aware Krakatau's back on the list. Shivaluch is probably still erupting, but not identifiable in satellite imagery. Mount Aso producing a 9,000-foot ash plume as it explodes. Sakurajima also exploding, 14,000-foot plume there. Sanjiang Api issued some kind of a report. Krakatau, eruption there. 2,000-foot ash plume at Krakatau. One of the few volcanoes that's actually killed people in the past year. Tukono, continuous emissions there, 6,000 feet. Again, Krakatau did cause a tsunami earlier, late last year. Revenador, new emissions there. Sabancaya, intermittent emissions. Copihu, continuous ash emissions. And Nevados de Chilean, down there in central Chile, exploding and producing a 13,000-foot ash plume. Here's where I don't know what that is. That's where stuff is in the solar system. That's what's up. And there's where it'll be in 1 week. But more importantly, here's where it'll be on 11/11. We're leaving this up. The transit of Mercury is going to happen on 11/11, folks. So get your eclipse glasses, get your binoculars, get your telescopic cameras all set up. We want to see images from our viewers. And by the way, thanks for sending emails, viewers. We are more than interested in putting your content on the channel. So anyway, there's a transit of Venus, of Mercury, where Mercury passes in between the Earth and the Sun. It looks kind of like this. But this is actually going to be a better one as it goes very close to the ecliptic. Now, the best place to view it is going to be in Central South America. But places like where I am will be able to view it. So I'm looking to get myself some eclipse glasses and perhaps get some photography going myself. We'll see. Again, links to this article also will remain below the videos all week until this occurs. Here's a current lightning map, courtesy lightningmaps.org. And next time you hear thunder, check that out perhaps. Next, we're going to, before we get into some deep weeds, we're going to look at the U.S. Doppler radar map. As it continues to snow in the central and north central and even the northwestern U.S., please leave a comment if you've got insane snow totals for November 6th, where you're located. And let's move on to all kinds of urological subjects. Starting with, do you have an open door pee policy at your place? If you want, have you instituted an open door urination policy at your residence?
I'm thinking of instituting an open door urination policy.
Please leave a comment. Let us know if you have open door or closed door urination policies. We're very interested. Now, let's talk about climate change real quick. Now, here's an article from phys.org, which talks about global warming every day, and practically every article, if you click the Earth section, nearly every article will have some sort of osmotic reference to global warming. And anyway, this one's about ship tracks, and I'm not really going to cite the article. I'm just going to state one thing. Ship tracks are a net cooling effect on the planet, as there is sulfur in their fuels, and some of that sulfur is getting into the air the same way a volcano gets sulfur into the air, and it's causing cloud nucleation. Now, those are ship tracks. Some of those lines that you're seeing there, these are not the ones that we feature on the channel that are electromagnetic lines. These are actual ship tracks, and because this is very zoomed in, folks, it probably has a resolution higher than 2 kilometers. So, but in any case, if you live near an airport, or if you live near the coast where there's a lot of ship traffic, those are net global cooling effects, or those are going to cool your local climate, as these things cause cloud nucleation, which is effectively an increased albedo in that area, which reflects light back into space. Have you ever noticed how a cloudy day is cooler than a sunny day, folks? All things together, all things combined, a cloudy day is, if you just take a normal day and just add a layer of clouds that reflect sunlight back into space, does it make you cooler or warmer? Now, this doesn't mention at all the fact that these ship tracks increase the albedo effect, and frankly, I don't care, because it's very difficult to click this thing and read the articles on phys.org, as everyone talks about carbon dioxide and how it warms the planet and yada yada yada, the radiative heating effect from a gas that comprises 0.04% of the atmosphere, and so on and so forth. Let's get deep into the weeds. Now, Dr. Tatu Kamau wants to cut off clitorises. Now, this is some legislation trying to be passed in let's see, in Kenya. Please leave a comment if you have theories about whether clitorises should be removed. And who told you so? Let us know if it's a cleric or a doctor. Now, Dr. Tatu Kamau is a doctor, apparently, at least according to the caption below this image. Let's talk more about the same exact subject. Were you aware that it's important for reproduction and not just sexual pleasure? Well, we've left links to this article also. So, yeah, I think there's ample evidence to suggest that this is a bad idea. Literally, this paper that she's holding up is a bad and stupid idea. Again, please leave a comment if you have an opinion. Next, we'll look at the U.S. water vapor map after I animate it. And please leave a comment if you're more animated than Skeletor at 4 o'clock in the morning. Now, I go to bed at about 7 p.m., folks, and that's part of the reason why I get up at 2:30 a lot of the time. Anyway, let's zoom back in on this convergence zone over the Four Corners region, as it looks like a giant, well, let's talk about this giant line of dry air here. Does that look like a giant electromagnetic field force line that's conducting positive charge? Now, keep in mind, folks, I'm not being facetious here. Dry, massive air like this has more protons. And that's, yeah, let's just zoom in. Did somebody know something when the Four Corners region, where these state borders were established in that location there? Because is that a coincidence? Does that look like a spiral to you folks? Just saying. Yeah, I'm not going to get into the weeds on this one today. But you see all those parallel lines in there, folks? Those aren't contrails, and they're not ship tracks. Anyway, this region right here is where there's an extreme pressure gradient. And so if you're flying a plane across that area, expect some turbulence. And if you're flying a plane across, like right across this border line right here, expect constant turbulence. And here are the Eastern Jets on Null School. We'll spin this around in a moment, show you the jets of the western world. We do see a big kink in the southern jet stream there. And there are the western jet streams. Please leave a comment if you've noticed a difference in the quality to the video. We've been tweaking video settings. Let us know what you think of that, if anything, if you've even noticed a difference. Now we are seeing a huge bend going from south to north, so we're going to expect to see some reports of extreme heat in places like France and Germany. Are you censored on the internet? Do you know the difference between censorship and a sinkhole? Do you know the difference between your you-know-what and a hole in the ground? Well, that's why we have this section. It's the section where we talk about whatever we want, such as where we ask you if you've pressed like and subscribe on YouTube, as we've gotten all the way to 1,400 subscribers. Whoa! Anyway, we know YouTube shows you ads, and we do have the channel monetized, but we'll get back to that in a minute. Do you follow us on Facebook's junkware app known as Instagram? Now, this thing almost works. It almost works. And so follow us there. Perhaps you'll see some information that you don't see otherwise, as we use this to link to videos and amazing cloud photos like this one that I took a couple days ago, and so on. So check that out, Instagram.com/smAsho. Also on BitChute, as it is a fail-safe backup, as it's less likely to delete our entire channel than YouTube is. It also gets us all of our views. So you can see a week ago we had problems on YouTube's junkware site, and so we ended up with 142 views there. Actually, that's about twice as many views as we got on YouTube that same day once we finally got it up. And when I say got it up, I mean got the video up. And check us out on Patreon. Patreon.com/smAshomash is the real source of funding for these videos, so please support us there if you are able, as YouTube pays us $0 for these videos. Coming up with a different excuse every week, let's talk about Voyager 1 and 2 once again. Were you aware that Voyager 1 and 2 have left the heliosphere and are now in interstellar space, and they're still able to send back a signal for at least a few more years, we're expecting? Anyway, the plasma density is much thicker outside the heliopause, as there is some sort of a galactic wind coming in. Something very interesting. We'll be very interested in looking at more data about this in the coming days, weeks, and months. So this is a super interesting scenario, and it's also a great way to study the real effects of cosmic ray flux. Or I should say, not even really the effects. Like, we're not talking Earth effects. We're talking about where do they come from? How do they work? How does it all work, folks? Part of the point of this channel. And links to that article, as well as this one, diffuse X-ray emission detected around the ultraluminous X-ray pulsar, with the catchy name of NGC 5907ULX-1. And it is an interesting object, to say the least. It has a diffuse X-ray shell around it, and it has been studied pretty in depth. It does have an isotropic wind, and we've got some more links to this. So links to the previous article as well as this one below the video. And we've done a little bit of extra research here. And we did find the galaxy here on Neil Gorell Swift Observatory, 3C399-1. And you can look at the transients of that if you like. You go to the Neil Gorell Swift Observatory, just type in Find 5907. Another catchy name for a galaxy. This is, I believe it's a Seyfert 1 galaxy, 3C309-1. And we actually just saw some very powerful transients coming out of it. How do you like them apples? Yeah, some of the strongest ones we've seen in quite a while just happened. Also, we dug up a paper about 3C309.1. It is a very interesting galaxy. And it has an oddly one-sided looking jet. Now, it's probably because we can't see the other jet because something is obscuring it, but this is a super, super in-depth radio analysis of it from all the way back in 1997, and this is just another prime example of the way old data in astronomy really doesn't ever expire. It might be applied to a different algorithm to create a different model, but this is super important as we have these shells. These are like pulsations, probably, where this thing is, it's active, and then it's inactive, and then it's active, and then it's inactive, and then it's active, and then it's inactive. You know why it's relevant, folks? Because all stars are variable stars. All of them, including the local yellow dwarf. There's no such thing as a stable star. Moving on. And what to? It's to make fun of Star Wars. Now, I used to love Star Wars in about 1983, and since then, it's gone down, down, downhill as the ads for advertisements started when I was 1 year old, and they've never stopped throughout my entire life. If there's anything I would like to melt down and form something useful out of, it would be Star Wars action figures. I can't stand Star Wars, especially since George Lucas ruined the entire franchise with the release of Episode 1, 2, and 3, three movies so pathetic that they're unwatchable. Let's talk about the Kessel Run. Now, Han Solo famously bragged that he made the Kessel Run in less than 12 parsecs, and it all gets explained in here. So if you if you want to read about it, yeah, well, it turns out that what he meant was that he took a shortcut because George Lucas didn't know what a parsec was, and he probably still doesn't know what a parsec was. If you're wondering what a parsec is, it's a combination of parsec and parallax, and it's just a measurement of the sky from the Earth, not a real like linear distance. It's talking about arc seconds. We're not talking about like light years, although it is 3.26 light years. Can we please just measure stuff in light years instead of parsecs? Thanks. And thanks for tuning in, Smash Team. We've got a couple of bonus features, so don't go anywhere. Let's nerd out hard. Let's make fun of Dungeons and Dragons. Now, I used to be a dungeon master. And one of the lamest monsters in the whole game is the Piercer. Oh yeah, the Piercer. Now, if you want to really piss off your characters, here's what you do. Have them enter a cave. Have a room full of these monsters, which are referred to as vermin. They're literally stalactites that are alive that have eyes on them. And then sometimes whole rooms of them will try to fall on your party and impale them. Isn't that a pathetic monster? Please leave a comment. And part of the reason I'm saying this is because I know a lot about monster folklore and all that sort of stuff. And Piercers are one of the most pathetic monsters to have in a D&D campaign because they're practically unintelligent, they're neutral in alignment, and their only job is to try to pierce people. And if you look at the Generation 5 stuff, this monster is even more pathetic than it was back in the 1970s when it was initially invented in Monster Manual 1. The Piercer, one of the lamest monsters in D&D, as it is not even part of human folklore. And we've got two more bonuses here. We're going to look at 304 angstroms of the local yellow dwarf. We're looking at about 8 hours here. There's the north, some filaments up there. Here's the south. I would note that active region rising there over in the east. And last but not least, my personal favorite, the 171 angstroms view. There is still a filament over there in the northeast. We've been watching this for days. There's the equatorial view. And here's the South Pole. We are out. Thanks for tuning in, everybody. Again, please support the channel in any way that you are able, as we are in a massive growth phase. It'll be an interesting winter. So may that solar wind be at your back, and may that atherosclerosis be absent from your veins.